Hi folks, welcome to this video where we're going to do an example like question number 1 on the central limit theorem homework with the means, okay? So let's take a look at question number 1. It says, suppose the age that children learn to walk is normally distributed with a mean 12 months and standard deviation of 1.2 months. 13 randomly selected people were asked at what age they learned to walk. Round all answers to 4 decimal places where possible. And so I actually want to begin by sort of thinking about this in sort of 2 separate pieces, okay? So up until now, we've looked at this idea of a normal distribution, and that has been based off of like the population, right? We take a bunch of individuals and we look at their distribution. But what's different about this question, though, is now we're taking a sample of the population and taking their mean. And that's where that second piece of information comes into play, right? So 13 randomly selected people were asked what age they learned how to walk. And so if we sort of read a little bit further down for a moment, we'll see that we have things that are asking about distributions of the whole population and then distributions that have to do with just the means. All right. So we're taking like a bunch of samples, taking the means of the samples. All right. So let's take a look at part A. It says, what is the distribution of X? And so in this case, we're looking at sort of the age that children learn how to walk. And so this is a reminder of going back to like our chapter 4, I believe, where we're looking, oh no, chapter 6, where we're looking at the normal distribution, okay? And so we have this X squiggle N, and in the first box, we're gonna put the mean, and in the second box, we're gonna put the standard deviation, okay? So when I look at the question, I see that the mean is 12 months and the standard deviation is 1.2 months. So on the My Open Math screen over here, I'm gonna go ahead and type in 12 for the mean and 1.2 for the distribution, okay? Now, that is exactly what we're getting when we do that, okay? So we submit the question, we get 12 and 1.2. And that 12 again is the mean and the 1.2 is the standard deviation, okay? But the next question, it kind of looks similar. It says, what is the distribution of X bar? Or meaning the distribution of the means, okay? So when I see something like this, right? And let me zoom in a little bit. This first box is still gonna be the mean, right? But the second box is the standard deviation of the mean, okay? And so in order to fill in this box, we need to take our standard deviation and we're going to divide by the square root of the number of samples that we have, okay? And so in this case, we're going to take 13, I forgot, not 13, we're taking 1.2 and we're dividing it by the square root of 13 because there's 13 randomly selected people, okay? And when we type that into the calculator, we end up with 0.3328, all right? I'm just gonna go over to the My Open Math screen and I'm gonna type in 12 for the mean and then the standard deviation of the means is going to be 0.3328. Okay. Now we'll check those at the end, but it'll just be a place where we can sort of keep track of our answers. Okay. All right, now one thing to think about here. The means are the same, which means the middle of this bell curve, and I know that it's a bell curve because it's normally distributed, the middle of the bell curve is the same. It's going to be 12. But when we're looking at the distribution of the means, the thing that changes is that the standard deviation makes the bell curve much narrower. So instead of a standard deviation of 1.2, we have a standard deviation of 0.3328. Okay. Now, let's think about this central limit theorem. Okay. So the central limit theorem, in order to use this central limit theorem to find the probabilities, we need to make sure that one of two conditions is true. Okay. So the first condition that we need to make sure is true is that the population is normally distributed. Okay. So either the population is normally distributed or we have a sample size greater than 30. So one of these two things has to be true. And if we look at our question, we can see that right off the bat, they tell us that our population is normally distributed. That means we fulfilled one of the conditions, and that's all we need. And if we look, the sample size is 13, so it's not bigger than 30. All right. So, in other words, we have to know that this is normally distributed. And that is actually our answer in part E. Okay. So it says is the assumption that the distribution normal necessary. And we're going to go ahead and click yes because we don't have a we don't have a sample size larger than 30. Okay. Now, if I said it's normally distributed and I had 31 randomly selected people, then my sample size is bigger. I don't actually need to know that it is normally distributed. Okay. All right. So now that we know that the central limit theorem applies, we can take a look at part C and part D. Right. So what is the probability that one randomly selected person learned to walk when the person was between 11 and 13.5 months? Right. And so to do this, we're going to go right ahead, go back to StatCrunch. Okay. So once we go to StatCrunch, we're going to go ahead and open it. And we're going to go to the same place we've been going all the way back in chapter 6. We're going to go to stat. We're going to calculator. And we're going to normal. Okay. Now, I want to know the probability that the average age or the probability that a person learned to walk between 11 months and 13.5. So I'm going to click the between. All right. I'm going to type in the mean that I had. So let me. Whoop. All right, so let's say that this mean is going to be 12. And our standard deviation is 1.2. All right. And we want to find the probability that it is between 11 months and 13.5 months. And we click compute and we get 0.69202185. And now we have to round to 4 decimal places. So the number I'm actually going to type in is 0.6921. Or sorry, 20, because I'm not rounding that 0 up. Okay. All right. Now, because the central limit theorem applies, look at this question in D. For the 13 people, right? So the ones that we randomly selected, we find the probability that the average age that they learn to walk is between 11 and 13.5 months. So remember, we have the same mean and we're going to have a bell curve, but we're going to have a much skinnier bell curve. We got to go back here and change our standard deviation to 0.3328, which is what we found earlier. Okay. And now we can go ahead and click compute. And you can see like pretty much the whole bell curve is colored in here because we're looking at the distribution of the means. Okay. And so if we round to 4 decimal places here, we're going to type in 0.9987. Okay. All right. So Part D is the assumption that the distribution is normal necessary. Yes, because we only chose 13 people. But if we had changed that to like 31, 32, or anything over 30, then we wouldn't need that assumption. Okay. All right, let's take a look at part F. Part F says find the IQR for the average first time walking age for the groups of 13 people. Okay, so we can still use this calculator here. And what we're going to do instead is we're going to use it backwards. All right, so we're going to say now we want to know, uh, let's see, we want to know where quartile one is. Quartile one is where the first 25% of the people are, which means that 0.25 is what we hope to get out. Like we're shading the first 25% of that bell curve. Okay. And we want to choose the standard. We want that to be less than 0.25. We click compute and we see that quartile one is at 11.7755. Okay. All right, now to find quartile 3, we're going to do the same thing, except we want the 75th percentile, not the 25th. 75 or 0.75 rather, and that gets us a Q3 of 12.2245. And to find our interquartile range, remember that is just Q3 minus Q1. And so when I subtract those, I get a difference of 0.449. Okay. Now I'm going to go ahead and type these answers into the MyOpenMath just to make sure that we've done everything correctly. We get 0.6920. We have 0.9987. We've got 11.7755. We've got 12.2245 and an IQR of 0.449. All right, let's submit our question. Everything looks great. All right. So I thought it would be useful for us to kind of see like what it looks like when we type things in, but also see all the calculations that we're doing off to the side and on StatCrunch. Okay. So I hope this video was helpful. Let me know if you have any questions and I will talk to you soon.